In previous video, we were discussing channels and unbuffered channels in particular. Unbuffered means that they can store only one value at a time. This video is devoted to buffered channels. Buffered channels have that name because apart from behaving as channels, they have a buffer of items inside. It means that if you send data, the execution won't block unless the channel's buffer is full. The same goes for receiving. Receiving won't block the execution flow unless the channel is empty. While unbuffered channels are very useful for execution flow control by blocking routine execution until a signal comes, buffered channels are widely used for implementing data queues. The main advantage before ordinary queues is that they are guaranteed to grant synchronized access, and they guarantee that routines don't eat your CPU time when trying to receive data from empty queue or trying to add items to a full one. Let's move to the declaration. The way to create a buffered channel is pretty similar to ordinary channels, but we also add the second argument to make the function call telling us the size of the buffer. This way you can think of the unbuffered channel as a buffered channel with a zero-sized buffer. Let's see the example that shows that the receive and send operations do not block the execution. First, we send 10 integers to channel and then we read them. Everything happens consequently. Let's run an application and we will see that nothing is blocked and the application finishes successfully. As was said before, the buffered channels are good for implementing queues. The most interesting thing about queues is dispatching. You have to understand if the producer routine produces data fast enough to fill the queue. There are enough workers on the other side to process the data. This situation is exclusive for every case, so you cannot just guess. But what is good about channels is that if either workers or producers begin to block, the CPU time is not consumed. So you can just monitor the behavior and tune the number of workers. Let's look at the screen to see the implemented queue, just to demonstrate the concept. Here our routine function starts at the beginning by reading from the in channel. It blocks until the recipient receives some data as the channel is empty. Then, in the main routine, we send the data. When the channel fills, the sending operation blocks and the switch to routine is performed, and sums begin to calculate on received values. Also, note the OK notation when receiving data from channel, and the close function at the end of the main. The close function is used to close channels. It means that the error will happen when we try to send something into a closed channel. Also, just receiving the data will cause receiving zeros all the time, and the for loop will hang forever. So we add a conditional break to avoid this situation. The OK variable will return 0 if we try to read from a closed channel. And the out control channel is used to signal that all the processing was finished in order to prevent the main function from finishing before time. This example is more complex but demonstrates almost all capabilities and powers of channels. And the last kind of channels we are going to discuss is unidirectional or one-way channels. It can happen that you accidentally send data into the channel when you have to receive it or vice versa. This is what a one-way channel declaration is used for. It signals the compiler that only receiving or sending can be performed from such channels. Let's change our routine header to demonstrate that. We have just added a receive operation before the chan keyword because in our function we are only going to receive data from a channel. Let's apply the same for the out channel, but restrict it to send only. In this case, we put the send operation after the chan keyword. Let's run the application to see whether everything works just fine. At this point, we have finished discussing channels and their features. Now you have to be able to operate channels and build more complex solutions based on the knowledge received. In the next two videos, we are going to discuss the most popular patterns of channels usage.